Thank you. So yeah, I'm here to present the work I did with my students, James, Hirav, Majed, on redirected teleportation. So most of us know that walking around using positional tracking offers the highest presence and is least likely to induce VR sickness. But unfortunately, natural walking doesn't really scale beyond the confines of limited available tracking space. Most people actually only free up enough space they have in their living rooms in order to play VR, and it's very small. So in order to navigate large environments, we have to kind of switch to an alternative locomotion technique that is generally activated using a controller. So right now, teleportation, as shown here in the popular zombie shooter Arizona Sunshine, is probably used in like 80–90% of VR games. And one of the desirable characteristics of teleportation is that it basically instantly translates the viewpoint. And so there's no optical flow, and thus you don't have any visual-vestibular conflict that could lead to VR sickness. But one of the drawbacks of teleportation is that it lets users navigate much faster than when you're walking. And it also takes very little physical effort to activate teleportation. So it's been argued that whenever you offer teleportation as a locomotion technique in your VR experience, this could kind of lead to lazy gameplay with users basically abandoning natural walking input, as switching between walking and using a controller is kind of cumbersome. And you can kind of see a little evidence for that. The little guy in the corner, he actually doesn't really move very much, basically stands still. And so, you can look at a bunch of videos and see the same observation that people actually don't really, there's a very little positional displacement when you use teleportation. So we did a little study to kind of develop a better understanding of this. So we picked 3 games that primarily rely on teleportation, which are Arizona Sunshine, Budgie Cuts, and Raw Data. And had 5 people play the first level for about 10 minutes, collected the positional tracking data, and then created heat maps. You can kind of see that people pretty much are stationary, either stuck in the center or at the edge of a tracking space. And so I think this is kind of a little bit of a concern. It certainly makes you wonder that, if people don't actually move very much, then why would you dump $2,500 on state-of-the-art VR system, right? Because you could basically capture those motions with a mobile VR headset. You would have to figure something out for tracking the hands. So we kind of figured we should maybe look at teleportation a little bit more closely, see what's going on, and see how we can improve it. So one observation we made is, it's not necessarily that people are lazy and they don't want to switch between walking and using a controller, but sometimes if you navigate in a single direction, here for example, people kind of get stuck at the edge of the tracking space and there simply is no room to walk. So in the past, people have looked at this and come up with ways to kind of reset the user position. So techniques by Williams and Bruder. So you get to the edge of the tracking space and then you can either freeze a simulation, make a 180 degree. And so those techniques are a little bit obtrusive. I think presence is very important for VR. And if you have to make a 180 turn, that's a little bit disruptive to the gameplay. So our approach was like, well, what if we modify teleportation in such a way that whenever you cast a teleport, it tries to increase available walking space. So this would kind of work a little bit like this. So whenever you run at the edge, it tries to redirect you back to where walking space is maximum, which would be in the center. And we try to do this in a more subtle, preferably non-obtrusive way, so the user is unaware of that. So we can maintain a high presence. So inspiration for this approach came to me through this game, Budgie Cuts. I don't know if anyone's played it, but it's an amazing game. And so one of the cool things about this game is it lets you teleport, specify a destination to teleport to, and then it shows you kind of a really cool preview on the side of your controller. You can kind of like peek around. And so I really like that idea of kind of teleporting using a portal. And another cool thing about this portal is also that it allows for a more seamless viewpoint transition, so it could kind of minimize spatial disorientation. So we set out to design a technique that we call redirected teleportation, which uses a similar portal. So you basically select the location to teleport to, and then a portal appears to your left or to your right, depending on which direction we try to redirect you. And so the idea is basically, instead of having users activate teleport by pressing a controller, we require the user to kind of actually step into the portal, so we kind of enable some displacement. And because the portal is either rendered to your left or your right, you kind of also have to rotate a little bit to get into the portal. And so we kind of force the user to kind of turn, and then what we hope to do is to kind of turn them away from the tracking space boundaries. Another thing we do is we do render a preview of the area you're going to be teleported to, and then what we do is also a slight reverse rotation of the preview, so that when you step into the portal and you were intended to go this way, you kind of end up a few degrees off, and then the user will kind of correct their heading in the direction they were going, so you can kind of create a little bit of extra rotation. Here's more details how this works. So basically, the user casts a portal appears, the user steps into the portal, so there's a little bit of a displacement. So we reposition the user, so they sidestep into the portal with a distance d, and then the portal itself is rendered at alpha degrees, and so to activate teleport, you kind of translate distance d, rotate distance alpha, and then with the preview, that's an inverse rotation of minus beta degrees. So every teleport, you kind of rotate a alpha plus beta degrees. And so that way you can kind of, using a number of teleports, rotate the user back to the center of the tracking space. And so you can kind of specify this as a 3-tuple, the number of teleports you need to rotate a user about 180 degrees. And so these values, alpha, beta, and d, you can kind of play around a little bit with it. So you have to be careful not to make those values too large, for example, for d, because then the user may actually step outside of the tracking space. And then with alpha and beta, you can crank it all the way up, but then it'll allow you to redirect the user faster, but it'll obviously become more obtrusive. So you have to kind of find out what the right parameters are for your tracking space. So here's a quick video of how it works, and we just illustrate it for a straight hallway. So the user kind of navigates in virtual reality in a straight hallway, but in real life, you kind of go around the tracking space. And for comparison, here we show the tracking space utilization. So a trace, where if you use regular teleport in one direction, so you would kind of get stuck in the corner. But with redirected teleport, you kind of circumnavigate the edges of the tracking space, and we allow for more walking. So this is kind of interesting, suggests that this would work. Of course, we have to do a real user study to figure out whether redirected teleportation actually increases walking. That's what we did. A user study with 14 participants. We decided to do a coin collection task, so we know the user has to pick up a number of coins so we can cover the whole space. We use a 2x3 study design with teleportation method and navigation type as independent variables. So the navigation type, we designed 3 different environments: a long hallway, a square hallway, and an open space, so we can kind of understand better whether this will work for different environments. And then we measured the number of teleports that users issued, total time, distance walked, and the tracking space utilization. So for the experiment, we used the HC Vive and the TP cast, so people could run around untethered. We used the tracking space of 2x2 by 2x4 meters, which, according to a survey by HCC, is kind of like the average tracking space that people have set up in their home environments. It's small enough that you are actually required to use a lot of teleportations to navigate large spaces. And then we use kind of these values for our parameters. And these are kind of a little bit extreme values. We also figured out that alpha has to be under 45 degrees, otherwise you won't actually be able to see it, because VR headsets have a fairly small field of view. So 45 degrees is just in your periphery. And so we kind of use these extreme values so users can be redirected in 3 teleports about 180 degrees. Kind of pushing for the extreme case so we can kind of figure out whether users liked it or not. So here are the quantitative results for the 3 environments and the 2 techniques tested. So to keep the comparison fair, we did subtract for redirected teleportation, the distance that user had to walk inside the portal, because otherwise they wouldn't fare. They have to walk into the portal in order to be able to activate it. So we subtracted that. But even that, we found significant differences for teleportation technique for the number of teleportations. So redirected walking requires fewer teleportations. It does take longer, but that's also because people walk more, and walking takes longer than using teleport. So they traveled larger distances, and they use more of the available tracking space. And certainly for this coin collection game, it becomes actually faster to actually walk to the coins to pick them up than to teleport. And so the task that we used for the user study definitely was able to elicit difference between these two techniques. Qualitative results. So we did find a significant difference for things like learnability, likability, and disorientation. I'll talk about that on the next slide. So just some general observations and limitations of our study. So redirected adaptation shown that it enables more walking inputs and allows for larger usage of your limited available tracking space. It requires fewer teleportations, so that's probably a good thing too. Also considering that teleportation can lead to spatial disorientation, so fewer teleportations could lead to less spatial disorientation. The benefits of redirected teleportation are definitely greater when you're heading in the same direction, and surprisingly a lot of VR games actually have these really long, like Arizona Sunshine, they have these really long elongated levels, so there the benefits are greater than when you have an open space. But it comes at a cost of lower learnability, and users also kind of preferred regular teleport over our technique. So it does take more time, but we have to kind of place that a little bit into context, because obviously they were walking more, and walking takes more time than just instantly translating a position. So regarding spatial disorientation, we noticed something interesting. There was one user who complained about getting dizzy, because obviously when you go into a straight hallway and you have to run in circles, people kind of get dizzy. So they felt it was more disorienting. But again, that's kind of the extreme case. And teleportation in general is already considered. There's many studies that show that it can cause spatial disorientation, because the instant viewpoint transition, there is no optical flow that can allow for path integration, estimating how far you travel. So that's kind of a generic problem with teleportation in general. Now, presence is also very important, but we specifically did not assess this for the following reason. There's many studies that show that teleportation has a low presence, and so we were basically comparing two forms of teleportation, and it would make more sense in a future study to kind of have a baseline locomotion technique that has a high presence. So compare redirected teleportation with real walking input, or walking in place, for example, to kind of better assess which one has a higher presence. So for future work, we're working on this right now. It's kind of cool. I don't know if you've seen this. There's a game called Robo Recall. It lets you actually specify your orientation post-teleport. So basically using your wrist, this is kind of a demo. Using your wrist, you can kind of like specify your orientation after you teleport. And so great opportunity to also apply some redirection. So for example, if I specify my rotation to be 90 degrees after teleport, but I'm actually facing the edge of the track space, what I could do is maybe just only rotate the user 70 degrees. So when I teleport, I'm like 20 degrees off, and I'm kind of forced to do that 20 degree rotation myself. And so we're working on that right now. That's it. I'd be happy to take any questions. Whoa.
Okay, so we actually have time for one or two questions. So in the meanwhile, I would maybe like to ask you, it was a very nice talk, but something, I mean, it's a bit tricky, because on the one side, teleportation is usually worse for your spatial orientation and all that.
Yeah.
On the one hand, you've got the portal, that sort of helps, but then on the other hand, you also have like the rotation of the scene, that beta degrees that you're rotating them. So in a way, it's like after I teleport, this that used to be 45 degrees to me, now it's no longer there. So on the one hand, it can help. On the other,
yeah, I think it was only one or two users that really observed that their post-teleportation orientation was off. But it kind of motivated us. I think those values for beta, I think you can crank them up even further. I think very few users know. But I mean, I like it. So teleportation can lead to spatial disorientation. But there are some new implementations of teleportation, and actually a paper that we worked on, where it is basically kind of half a second of optical flow. And so that doesn't actually, it's not large enough to lead to visual-vestibular conflict, but it is large enough to allow for path integration. So you can test, you can estimate how far you travel. And you see that a lot already in certain games. To remember, I think Robo Recall has it too, where you kind of like dash towards the location.
That's pretty cool.
So I'm kind of curious because the way you describe it, it sounds like they have the option of teleporting or not, or they can just walk, right?
Yeah.
So eventually, if you have a user who refuses to teleport, they're going to run into something.
Yeah.
So you have to use one of these other techniques of, forcing the game to stop or whatnot. But since teleportation is helpful in preventing that, I'm wondering, are there ways to further incentivize the use of teleportation, of giving them a reason to do it other than just getting somewhere?
Yeah. So, we kind of primed our task to kind of really, so you have to pick up these coins. And so if you just were to teleport, you would have to teleport to every coin because you can't really walk to it. So at some point, people would figure out, okay, with redirected teleportation, you can actually walk to a few coins. You can pick up a few extra coins while walking. And so for this specific task, we kind of boosted walking input. But I think if you just play a first-person shooter or something, I think people would still primarily use teleportation. And I think enforcing people to walk is just really difficult. So yeah, in our context, we because of this specific coin collection task, people figured out that walking to a coin was faster than using teleport. So there was that worked out for them. But for real games, I think it will be very difficult.